Shalom Rotem.
Shalom Danit. In this episode, we talk with Justin Searle, a SANS instructor who flew all the way to Israel. Justin was grabbed for a quick interview with us, and we learned that he has a few unique hobbies and occupation. Now, without further ado, let's start with the episode. Hello, Justin.
Hello, how are you doing?
I'm great, thank you. Maybe you can introduce yourself.
Yes, so my name's Justin Searle. I do cybersecurity and industrial control systems for a living. My background, from a college perspective, I have a bachelor's degree in technology education, so always have been interested in education, but a minor in computer science and a minor in electrical engineering, then a master's degree in international business and information systems. So first full-time job I ever had was working for an engineering firm, building control cabinetry for water treatment facilities. After working there, I decided to go to the dark side and work in the IT world and do cybersecurity for IT. So that was probably the first 8 years of the career, and ended up being the security architect for JetBlue Airways, redesigning their infrastructure, becoming PCI compliant, dealing with security in IT, but also in OT, because we did have baggage handling systems at 53 different airports and many different aircrafts that we had to deal with, and security inside of the aircraft, as well as when it docked at each of the terminals at the airports. So since then, it was about that point after JetBlue, I changed my career focus and started focusing on security testing. And as I started doing security testing, one of the first clients that came to us was an electric utility, and they wanted us to come through and do security testing of some new smart grid automation capabilities, as well as some new smart meters that they were considering adopting back when smart grid was the new thing on the block. And yeah, for the last 12 years, that's pretty much what I've found myself stuck doing, is doing security testing inside of industrial control systems, from the energy sector to oil and gas to aerospace manufacturing, auto manufacturing, food manufacturing, chemical, pharmaceutical, to avionics, to shipping yards, to trains, subways, microgrids for military bases, nuclear power plants, as well as, to some degree, a little bit into weapon systems, as well as nuclear-powered military devices.
Impressive.
Yeah, I'm really impressive. So
it's honestly, it's just a craving for more knowledge and craving to satisfy my curiosity. So honestly, my determination on whether I take a job on or not is usually if it's in an industry or a field or a control system that I have not experienced before. That's always the very first yes, right there. And then same thing for countries, right? If I have not been to the country, the answer is yes.
So how is Israel?
Oh, I love Israel. It's been great so far. I've been able to get out and see a little bit, and after finishing class, I'll have another extra day to be able to go play, and definitely will be back.
Oh, that sounds really good. A real adventure.
Yes, always. Life should be an adventure, right? That's what makes life interesting.
So you literally the author of the course, that 410.
Yes.
How did you get that?
Oh boy, I've authored many courses over my career. So I've always enjoyed education, right? My bachelor's degree was in education. My goal was to be a professor, and I did that for a couple of years and realized that I didn't want to be a full-time professor, full-time education. And so after I was, took a short professorship for about 2 years, I ended up starting to do public speaking at different security conferences, and then started offering workshops at conferences, and then starting to go ahead and provide training and write training courses, and started doing training at OWASP events for cybersecurity around web applications, started doing training courses at Black Hat, been doing training courses at Black Hat now, for teaching there for about 13 years. And then 2 years after that, so about 11 years now, started teaching for the SANS Institute. First it was in penetration testing around web applications and other types of web technologies. And shortly after I started, that's kind of when I made that transition into cybersecurity and doing pen testing and cybersecurity full time. And now I've written a couple of courses around them. So I have 2 or 3 courses that I still currently offer and teach, and have a small army of people to teach with me.
So Danit, you need to hear some crazy hobby hobbies that this guy had. You must say something about that.
Yes, I love scuba diving. I love scuba diving. I'm actually a scuba diving instructor and a master diver. So yes, that's what you were talking about, right?
He's just playing with us.
No, actually I am. I am a dive master for scuba. And I'm working on my helicopter's pilot's license as well. Almost finished with that.
Wow. Are you pitting the helicopters too before you...
Am I testing the helicopters?
Yeah.
No comment.
A pentester is also working.
But my wife is a helicopter pilot, so she's a commercial pilot, and so I'm trying to get my pilot's license to do it. But I assume you're talking more about the falconry, the training the hawks and the falcons. So one of the biggest problems that my wife and I have is we have way too many interests, way too many hobbies. Like I said, life should be an adventure, and I believe that in both my work and in my personal life. And besides the many outdoor activities and the way too many open source projects that I run, my wife and I also are licensed falconers. So we train hawks, falcons, eagles, and owls to hunt.
The birds?
The birds. So I've been doing that for 18 years now, actually 19 years now. And that's actually how I met my wife. So my wife and I met doing falconry back in 2000. End of 2012, beginning of 2013 is actually when we met, because we were both falconers, and I was practicing a very specific piece of falconry where I had two Harris hawks that were that I had trained to cooperatively hunt together, which is less common. It's not very common to have birds hunting together in falconry, and she wanted to experience that, and that's how we met.
Wow, that's great. You know, adding your experience in ICS and OT, and when on our podcast, Rotem talks a lot about how there are not enough professionals in OT and ICS, and adding this falconry, I think, Rotem, that you've met your new idol.
Yeah, well, sleep is something that I try to find between the hobbies. So that's what the airplane is for, between the travels.
So you probably travel far.
Too much. I usually, for almost 15 years now, I average about 350,000 miles per year. So I've been to 42 different countries, and most of those countries I've been to many times.
Wow, that's exciting.
Yeah, exciting and tiring, and the pros and cons. Let's just say that COVID for the last year and a half has been a very nice forced break. So...
Don't ask him what he learned in the COVID. Don't ask him.
Like I said, too many hobbies, way too many hobbies.
Okay, now I have to ask.
So during COVID, my wife and I, since I wasn't traveling and I had weekends, which I've never experienced before because I'm always flying on airplanes over the weekends, my wife and I started doing professional shooting competitions, and then started doing two-gun competitions, and then started doing night competitions with weapons lights, and then started getting into night vision and shooting with no lights at night. Which led us to the current birds we have, which are two small small falcons, so they are not falcons, excuse me, small owls, because as we started asking around, the only owls we have ever known anybody to hunt in falconry are usually the large eagle owls or great horned owls, and they usually hunt at dawn and dusk with lights to aid them. We have never found anybody that's hunted them at night with no lights, and since we had already invested in the night vision, we are now hunting or trying to train these birds of these small owls to hunt at night with no lights with purely night vision.
Wow.
So, and trying to get back to the scientific community, because the scientists know nothing of these small owls, because the small owls are not they like the big owls, so they invest money and research in the big owls, but nobody knows anything about these small owls. So we're trying to give back to scientists as well. So
wow.
Yeah.
I'm happy I asked.
Like I said, we sleep between our hobbies, mostly on the flights home.
Did you notice that it says that they're starting right at the professional level? It's not like, oh, we were just shooting around cans and so on. No, it's just straight to professional, and then competition, and now training all small owls at night. It's like...
I come from the United States. We grew up with hunting, right? So hunting was a thing in my family and my wife's family. So we had always had guns and shotguns for hunting, but to do it professionally, more at targets, right, in the competition was the new aspect, which was really fun and really enjoyed. So and ended up causing us to buy some more guns.
That's always good.
Not a bad thing.
Okay, so let's go back to professional.
Let's go back. Okay. So you're a pentester in ICS, Industrial Control Systems. How do you do it?
So that's the tricky part, right? Because inside of industrial control systems is an area that if we do something wrong, we can cause very, very grave results. And so we always want to be very careful. And so that's the balance, is trying to figure out what can we do for testing of a production environment compared to what should we not do in production and save for some type of a lab-based testing. We know there is risk to always test production, but at the same time, we know that attackers attack production. So any test that's done outside of production is only going to give you limited value. So we want to do something in production, but the careful thing is trying to find the right balance of what we do in production to identify risks and vulnerabilities, and then what do we do in a lab where we can really deep dive and find the zero-day vulnerabilities and report back to the vendors to try to address and fix the problems.
So basically you do not penetrating any ICS environment, you only penetrating the equipment.
So we definitely do not. So when we talk about the environment, right, because the environment's very large, probably the better way to say that is when we are doing penetration testing of production environments, we do not do penetration testing of the process and the controller, right? We try very hard to stay away from the process. We will usually, in a testing environment, we will usually only do testing in production after we have done other engagements where we investigate the risk and do architecture reviews and talk to engineers and understand the risks and understand the technology that's there. And then we'll usually collect data from the environment through network captures and analyze the network captures, not to find vulnerabilities, which I think a lot of people misunderstand what a network capture assessment is, but primarily to enhance our understanding of the assets, of the communication flows, of the protocols that are used, and more importantly, for the company doing the work, judge our own liability and our risk about going forward with sending packets and interacting with that environment, and making sure that what we see in the network captures matches what we spoke to the engineers about in the architecture reviews and their documents and their asset inventories. Because if what we learn from the engineers in the interviews do not match what we find in the environment, that is a cause of concern, and we need to address and remediate that and identify why we have differences before we ever do something even as simple as port scanning, because even port scanning inside of industrial control systems can be dangerous. So we will do some limited port scanning of the supervisory areas, the higher levels of the control networks, to identify the assets, identify the services, and very carefully interact with some of the IT services. But when it comes to the processes and the control protocols, we will try to identify the control protocols. If we're in a penetration test, we may send an identification request to the service to identify what asset and serial number and model number that's there, but we will not enumerate control protocols. We will not send read requests to the various different tags in the controller trying to understand the process. That is something that's best left for a production environment, or sorry, for a lab environment, lab testing. And another thing is we will never interact with the devices while they are producing whatever process they are doing. So generation plant for an electric utility, we will only test when it is offline, not providing power to the grid. Of course, the equipment is powered on, else you couldn't talk to it, but they're not actually providing power to the grid. So there's no risk of blackouts. And same thing with production, right? Food manufacturing, pharmaceutical manufacturing, we will test them while the devices are on, but the process is not actively producing something because that's too much risk.
When you explain your method, it's very interesting, but all I can think of is that if it's that easy for the attacker to abstract the control systems, then wow, that's frightening. If the defenders can't check or connect to the controllers, then just by connecting or reading to them, they can cause damage.
Yeah, and there is some level of truth. Generally, you can connect to them and you can read from them usually just fine. The problem ends up being with specifically how some systems react, where maybe you read too fast and a system has a problem with that, or you read some type of a value that doesn't exist because we don't know the values that the engineer programmed into them. So we really are trying to enumerate and try many possibilities. And sometimes a controller, if you ask it for a tag that does not exist to a number or an address that hasn't existed, and you do that too many times, sometimes it slows the controller down or causes something. So it's unlikely to cause problems, but there is a chance, which is why we avoid the risk. And it's just better to stay away from the process in production. If we want to test a controller to find out how good the controller is, if there's 0 days, that's when we usually ask for a copy of that controller to put into a lab, where then we can really beat it up, right? Do the real pen testing of that device and find the vulnerabilities.
I hear that the way you do all the PT is usually how the equipment communicate. I see people like Jason Larson that actually try to understand the process and maybe manipulate the process itself through hacking.
Yes.
Do you do something like that?
We do, but only in a lab setting, right? Because when you're inside of production, once again, we don't want to cause problems with either the production line they're producing or, more importantly, the equipment itself, which might destroy the equipment or cause injury to operators around the equipment. But we do. There's a specific type of test assessment that we offer that we usually call a controller logic assessment, where we put the controller inside of a lab-based setting where it's safe. We often have the controller there and may not have that controller connected to all the large equipment that's there, but just have the controller and maybe have a dummy or a simulated device that it's connecting to. And then with that logic loaded up on the controller, we will then go ahead and either write our own tool to interact with that controller using the control protocols, or what my personal preference is to go ahead and if the engineer has created an HMI for that process, which is usually the case, ask the engineer for a copy of the HMI and a copy of the credentials and software to edit the HMI. And I will actually start with the HMI as my testing tool. And I will then take the HMI, which has visibility and understanding of how to work with the process and can talk to the process already, add controls to be able to send different types of signals from the HMI that may not already exist by the engineer, and use the HMI as a testing harness to initiate a lot of the testing of the logic itself, trying to put the logic in some type of an unknown state, or trying to, often a lot of the logic is built into a state machine, try to put it into a state and see if I can fix it or make it stay in one single state while I manipulate other values outside of that state that maybe the engineer had not thought of preventing that type of behavior. And then if that works well and I need to do further testing or further proof of concept, then I can write my own testing harness for that protocol and then try to have more control over the protocol. But I found the HMI and repurposing HMI for a testing tool is the fastest way to test the logic in the controller, because the engineer has done all the work for you to help you understand what's going on in the process.
When I worked at the INCD, the Israeli National Cyber Directorate, one of my main interests was on medical devices. Mm-hmm. And now when you talk about the ICS and the industrial controls, I think that it's different because on medical devices, you usually have an operation system to run them, and it's quite different. And I wanted to ask you if you have any experience on the medical platforms. Mm-hmm. And then I have another question, but I'll wait.
Very good. No, definitely it's true. The medical systems really are just control systems, and we've done a lot of testing of medical devices as well, because when we talk about industrial control systems, it is an automated control process, which is the same we have in the medical devices. Just when we have medical devices, they're usually very, very simple, where they're only measuring 1 or 2 or 3 different elements and may have 1 or 2 different types of actuators or response. So for instance, a pacemaker that's monitoring your blood pressure and the pulse rate of your heart. And if they detect something that is off, they'll go ahead and initiate some type of a shock. So it really is very similar. It's the same. It's a control system, just like like an industrial control system. Just when we have an industrial control system that's producing or manufacturing some type of device, we end up having many of these smaller control processes put together into a larger hybrid type device that is just much more complex, much more expensive, and much more dangerous, at least to a larger number of people.
What do you think about the IoT wave that is starting to be all around us? Because it seems like a lot of, OT is coming everywhere.
Yeah, it is. And I think IoT in general is just that constant challenge we have as a human race that's comparing cost to benefit. Because when we have IoT devices are also a type of control system. Think of your thermostat in your house, which is an IoT device, right? Or some type of a light system that we have. All of these different things are simple control systems with simple sensors, simple actuators. So, kind of like with medical, it's still more or less the same. They often use different protocols than what our industrial control protocols work with, but from an architectural perspective, the same concepts of passing data from sensors and making decisions and making some type of a change somewhere else is still the fundamental architectural, similarity between all these different types of devices.
Do you think we'll see in the future a new profession for PT or testing IoTs, or will it be a part of the ICS or the regular cybersecurity?
I think we're already seeing a new profession lineup. We have people doing penetration testing professionally solely on IoT devices, and we do have ICS protocol, or not ICS, but we have IoT protocols that are unique and inside of IoT, and some of those, like MQTT, is one that started in IoT, very popular in IoT, that we're starting to see introduced inside of the industrial control system. So there will always be an overlap, there will always be similarities, but I think there always will be different people that specialize in medical, specialize in IoT, specialize in industrial, because there are different risks. And more importantly, I think there are different sources of funding and different companies that are engaging penetration testers for those areas.
There any tools that you can suggest to people want to understand or better understand the realm of OT and how to penetrate it?
So that's always a challenge, and that's something I've found in my career, that trying to identify tools, especially for ICS, is always a big challenge, especially when we're doing penetration testing, because we have a lot of tools in the ICS world, right? But those tools are primarily written for engineers, and they're usually created by vendors and usually sold either as a standalone product or provided as part of a larger acquisition that, number one, usually are not made available or easily obtained by people learning or performing penetration testing. And number two, don't really have all the features that we need for doing penetration testing, because I'm looking at a system and a communication protocol and a way a process and a supervisory system interact with each other in a very different manner than a control engineer. They want to build and facilitate the communication. I don't understand what they build. I need to analyze what they build and step away and find some way to take all this data and represent it in a way that I can start to learn what they did. I'm coming at it from a different perspective. So I've tried a lot of using the engineered tools, and I still end up using a lot of engineering tools and doing crazy things like building scripts and macros and monitoring this mouse movement and clicking on this one single button and doing it 1,000 times and saving it to a text file and exporting it so I can analyze it, which is horrible. It's not the best way to do it, right? But we are starting to see some penetration testing tools written specifically for ICS, and I've been trying to do that with the lack of infinite time that I try to find in my life. But I'm trying to, some of the open source projects I have is trying to provide and write some of these tools more to scratch my own back because I have those immediate needs, but also for my customers and my students to be able to use as well. So I have a website, controlthings.io, which is a website. I have a virtual machine that is a Linux namespace, virtual machine, very similar to Kali, but it's called the Control Things platform. And it has a lot of different types of network, IT, and ICS, OT penetration testings built into it, as well as a lot of data, a lot of reference material, a lot of guidance documents for defense and offense, a lot of network captures from ICS protocols, which are really hard to obtain if you don't work in the industry. And even when you work in the industry, hard to get the engineers sometimes to share. But so I have that platform that's there that works. And by the way, it's not based on Kali, but since it's based on Debian testing and Kali's based on Debian testing, which means we have the same parent, it means that my packages and Kali packages are for the most part cross-compatible. So I do have Kali repositories in the distribution. So if I don't have a tool and Kali has a tool, you can apt install, name of tool, automatically have it installed. But then I'm also trying to write custom tools because there are specific needs that we need in ICS with ICS protocols, which we don't have enough people doing this work to really write the tools, because right, it seems like you have to get 100 people before tools start to be written. Then you have to get 1,000 people in the industry before people actually start writing good tools. So I'm trying to be a help and write some of the good tools, but they're still incomplete. They're still in alpha stages. But the at Control Things IO, there's a tools page where I have several different tools, where I have various starts for various different types of tools, some protocol specific, some more generic that are dealing with more generic IT layers like serial layers, IP layers, RF layers, where I can interact with proprietary protocols and at least analyze fairly easily some of these proprietary protocols and at least make the requests. But like I said, that is a constant work in process, and I do that in the spare time. You know, sometimes I swap an hour of sleep to make a little bit more advancement on my open source tools.
Wow. Can we move on to our similar question corner?
Uh-oh.
Okay.
You guys have a coordinated question for me.
Yes.
Trouble.
Well, in our podcast in Hebrew, we have a set of similar questions that we ask all of our guests.
Okay.
These questions are meant for the cybersecurity work of line. And since you have so much experience in seeing what others can't see, then your perspective is very interesting. These questions are fast Q&A. Okay. So be prepared. We'll ask a question and a short answer, and we'll go back and forth.
Okay, very good.
What is the biggest challenge in our profession?
Getting things done. We have so much to learn, so much to keep up to knowledge, so much to plan, so much to determine what we need to do, that sometimes actually accomplishing something real is the hard part.
If you could recommend others who wants to be a CISO, wants to be a defender, a professional, what do you think the most important thing that they need to know, to learn?
Passion and dedicating your personal time after work to be prepared for the next step. Because if you're not prepared for the next step, you're not going to recognize it and you're not going to be ready to take it.
CISO that doesn't have any money, or literally small amount of money, what is the minimum barrier that he can do?
Oh, the minimum he can do. So not even enough to be able to hire a person. Because usually I would say hire a person before you buy a tool. Boy, that one's a rough question. Honestly, I think that from a CISO perspective, with little to no budget other than his own hours to be able to do the work, right? I would say try to spend half your time on planning and generating metrics and providing metrics and information back to the business and running a program, and probably the other half of your time trying to make changes here and there to make the security a little bit better, to stop the attackers from getting in or be able to increase visibility to see the attackers.
How do you think, or what do you recommend that we can bring more women to these professions?
That's always a challenge. I would love to see more women inside this profession, because I think that this is just an interesting profession. We need people, and we need the ability to be able to think from this from many different perspectives and many different angles. And I think really just outreach programs, working with universities, different types of benefits, and really just really encouraging those that are interested to push forward. And and the women that are inside the field, they probably know best, right? I definitely come from a different angle. So yeah, I would actually push that back on your shoulders and say you probably have a much better perspective than I have on that.
Yeah, but that's not for a quick answer.
No, that is true.
I can talk an hour about that.
So next question, risk assessment or PT? Choose one.
PT for pen test, I'm assuming. Risk assessment or pen test. I would say whatever we did the last quarter, last day, last week, we'd do the opposite because we need both.
And if we haven't done nothing?
If we haven't done anything between the two, probably risk assessment.
Or close the business. A good CISO, is he a manager or a hands-on technical?
Depends on how big your team is. If you only have a team of 3 people and you're the CISO and you only have 2 people working with you, you better be hands-on. If you are a CISO that has 20 or 30 people underneath you, you better not be hands-on because that's not what your skill set is, and you have people to do that for you.
What is the most important certification a CISO can have?
The most important certification a CISO can have. I am drawing blanks on that one. You know, a lot of people would say CISSP, and that measures some type of a basic understanding of cybersecurity. But honestly, I almost would lean for something, and I'm not even sure what it would be, but maybe something outside of security and more around project management, maybe around communication skills, maybe around management in general.
If that CISO was the CISO of a big plant or critical infrastructure, is that going to change your answer?
Yeah, I don't know. That's a hard one. That's actually a really hard question.
I thought you were going to say my course, but
well, my course will help. But I don't know. The GISSP that's tied to my course around industrial control systems definitely hits the balance between the two. But I don't know. I mean, that would be one option.
I know. That's a tough one. I know. So the last question is, what is we're talking here most in Israel,
yes,
but I think you can see better perspective globally, maybe. What is the biggest weak point that we have in security?
The biggest weak point that we have, resource constraints. We don't have the staff. We don't have the budgets. We are always undermanned, understaffed. Usually we have the tools. We don't usually have the people to run the tools or use them appropriately.
So how do you think our profession going to look like in 5 years?
Honestly, no different.
Just the same.
Just the same. I think we're going to keep on going on. I think we're going to be doing the same thing we're doing now, but maybe doing a little bit better, right? I think specifically inside of industrial control system security, I think that 5 years from now that there will be a little bit more awareness, a little bit more budget, a little bit more investment, a little bit more maturity that we have gained over those 5 years. But looking back over the 21 years that I've been doing this, right, it just seems like we're a forward progression, and I'm not seeing major changes. It's just more of a gradual maturing. So
that sounds really perspective.
Well, I mean, once again, I think it really depends on what we're looking at and what aspects you're looking at. But even if I look at something like penetration testing, I go back 15 years for penetration testing. We were still going through and using tools, and we were probing and we were identifying vulnerabilities. But when we identified vulnerabilities, we had maybe 20 vulnerabilities types that we would identify. So MITRE CWEs and MITRE CWEs today, we have 150 some odd different vulnerabilities. So we have better language, better descriptions, better categorizations. We have the MITRE attack framework that helps us try to define what we're doing. But in reality, the MITRE attack framework, for how amazing and new and wonderful it is, right? It's the same stuff that we were doing back then. It's just now it's actually written down and has better descriptions and better, divisions and paths that are there that has matured over time.
So we're closing up to the end of the episode. and I thought maybe to ask you if you have like a really, really nice story about something went completely wrong.
Okay, so here's a story, kind of funny, and it actually ties back into industrial control systems, because when we work in an industrial control system, the risk is simply different than what it is inside of the IT world. And luckily, this isn't super scary, super dangerous, but doing penetration tests, right, in the IT world, the biggest risk that we usually run across is, filling up garbage into a database, knocking over some type of a server, crashing some type of a service that customers need, and we get in trouble because we get angry at, right? So when we do penetration testing in industrial control systems, we're always very, very risk adverse, very careful with what we do, right? So we are much more careful inside of ICS. However, sometimes when you are working on an embedded device, we tend to be maybe a little less careful, a little bit less conscious of that. And so there was a period back maybe about 10, 11 years ago where me and another coworker were working on a penetration test of some smart meters. And, smart meter, pretty easy, electronics. We were doing a circuit board analysis. We were actually taking it apart and attacking the chips, trying to dump firmware, dump different configurations and calibrations off of the EEPROMs and flash chips and the system-on-a chips on the circuit board. And after I'd gone through and dumped all the information off the EEPROM, I had taken that back to my laptop and started working on it. My coworker went ahead and tried to attach back up to the circuit board and do capturing of the serial traffic. So when I dump it on EEPROM, my tool powers up the EEPROM chip so I can dump the information off of it. But when you want to do bus sniffing or capture the communications between chips on the circuit board, our capture tool doesn't power the board. Instead, we have a shared ground and our tool is attached to the board, but then the board itself has to be powered up under its own power. And my coworker had went ahead and done that, had powered it up. We were using syringes to touch the different points on the pin, because when you work on the surface mounted chips, they're really, really small pins, and even the best electronics probes that are out there, right, actually are nothing compared to a good syringe, right? Like the draw syringe when you're actually going to be drawing material out of some type of a vial, right? So the big heavy ones. We were using those. We had 5 of them, and trust me, if you're an electronics engineer listening to this, you have to go out and buy a syringe for 35 cents because it is better than anything that you've spent at the electronics store. So, but he was holding these 5 syringes on this board with one hand and working with his other hand, typing on his computer, initiating the capture, analyzing, making sure he had the right data that was actually there. And as he was trying to see it, he leaned forward to his computer to try to, see what he was actually capturing. As he leaned forward, the arm that was holding the syringes came closer to the circuit board and ended up hitting the power pads that was powering it up, which was 220 volts, which hit him and hit him good. I was working on my computer. I just heard a chair tumbling across the room and a yell. And so I immediately stopped and said, well, what's going on? What's going on? And we finally figured it out. And he's like, oh, I just got shocked. It's like, okay, well, that sucks. I'm glad I had my portion of the job and not your portion. And we talked about it. It's like, next time, instead of powering up the whole circuit board to the transformer to actually power the circuitry, it would probably be wiser to go ahead and use our own power supply and just provide the logic level voltage after the transformer and not deal with the high voltage AC current that was there. And it's like, yeah, we both agree, yeah, we need to do that next time. Yep. Okay, great. We went and resolved. I go back to my computer. He starts getting his stuff back together, gets his chair back, and I look over and he's looking around, and it's like, what's going on, Josh? And he's like, oh, I can't find one of my syringes. So I kind of stop and we go help and try to find the syringe. We found it. It was actually in his shoe. Through the shoe, between his 2 big toes. Luckily, did not draw any blood. That is the one downside to syringes. I guarantee if you use a syringe, you will never go back to an electronics probe, but I also guarantee you will bleed at one point in your career. So pros and cons, right? Risk versus benefits, always an evaluation. But then, yeah, to kind of finish the story, 15 minutes later, did the exact same things, but did not drop his syringes.
Then that's an improvement.
That is an improvement.
He learned something.
Yet we did not go back to the TTL level voltage to past the transformer.
Okay, Justin, thank you so much.
You're welcome.
It was really nice.
Yeah, it was great.
Oh, thank you.
And thank you, Danit.
And thank you, Rotem.
And thank you, everyone, for listening.
Bye.
Bye.